All right, so now we're moving on to talking about units. The International System of Units is what we're going to use, the SI system, and it's a revised version of the metric system. So these are the 5 base units we're going to use most often: the meter for length, kilogram for mass, though to be honest we're going to use grams a lot more than kilograms probably. Temperature is Kelvin, though we'll use Celsius a lot. Time a second, and then the amount of substance is a mole, and we'll talk about that a little bit down the road. So the basic unit of length is the meter. It might be more convenient to use something that has a prefix, and for those of you familiar with the SI system already, you know that it's all about prefixes. So no matter what unit you have, could be mass, could be length, whatever. If it's in the SI system, you can use prefixes, and it makes that unit bigger or smaller. So for instance, a kilometer is 1,000 meters, whereas a millimeter is 1/1000th of a meter. So depending on the prefix, it tells you how big it is. And now if you know the relationship between all of them, you'll be able to convert between them quite easily. So you'll have 10 decimeters in a meter, 100 centimeters in a meter, 1,000 millimeters in a meter, a million micrometers, and a billion nanometers in a meter. Same thing as with grams. If you have like a centigram, there's 100 centigrams in a gram. If you have a microgram, there's a million micrograms in a gram. For volume, the SI unit is the cubic meter. We are typically going to use liters and milliliters. That's a non-SI unit, but the prefixes still work the same. There are 1,000 milliliters in a liter. Also, a good thing to remember is that a cubic centimeter is the same thing as a milliliter. A cubic centimeter is a sugar cube. That's how big a cubic centimeter is. So that is how big a milliliter is. So if you're trying to figure that out, that's just kind of a handy reference. Also, it's about 20 drops. So there you go. I talked about this. You're familiar with the 2-liter bottle, so if you cut that in half, that kind of gives you a reference point for 1 liter. Mass, I've already told you a little bit about. The prefixes are the same. There are 1,000 grams in a kilogram, 1,000 milligrams in a gram, so on and so forth. It kind of gives you some references down here if you're wondering. So then we have derived units, and derived units are just kind of complicated units. So that means you have to do something, some sort of operation to get it there. So for instance, area, that's length times width. That's 2 lengths together. And so we get units that are derived because we did something to get them. Density is a great example. It's mass divided by volume. So it's a certain amount of mass in a certain amount of space. Molar mass and molar volume, we'll talk about those later. Energy is force times length, and we give that the unit of joule. So density is the ratio of mass to volume, or mass divided by volume. My high school teacher, he was a little bit strange, but he told us something, and I've never forgotten it because it's so weird. He said, if you want to remember density, remember dirty monkey vomit. Density equals mass divided by volume. So dirty monkey vomit. I think that's just strange, but I have never forgotten it, so maybe it'll help you too. I don't know. Kilograms per cubic meter is the derived SI unit, but most of the time we're going to use grams per milliliter. That is your typical density units. The density of water is 1 gram per milliliter. That's a good thing to put up in the vault. So if you have 100 milliliters of water, you have 100 grams of water. It's pretty cool. Just a little bit of a reference for you to kind of see. just because you have the same mass does not mean you have the same volume. Just because you have the same volume doesn't mean you have the same mass. You can use density to identify a substance. It's pretty nifty. So different solids have different densities, so on and so forth. Everything, as long as it's a different substance, they have different densities. Here's some densities. Also, density changes with temperature. So this is why they have to report the density at 20 degrees Celsius. If you heat things up, typically they expand. You cool things down, typically they condense. So you're going to, when you have something expanding, it's going to become less dense. So there you have it. There you have it. Some different densities, once again. Now, if you can discover the density of something, you can compare it to one of these tables and you can identify the substance. So if I just give you a random metal block, you can take the mass of it, you can take measurements and get the volume of it, and then calculate the density because you do mass divided by volume. At that point, you can check out one of these tables and use that to identify the substance that you don't know what it is. So that's all for this one. Come back for more.